Welcome to KCC Diesel Online. My name is Jeff Rush, and this is DST110h and AMT110h. So today's discussion is going to be on the ATECH board. So this is your intro to the ATECH board, the circuit boards we're going to be building in lab. All right, ATECH boards are not toys, okay? They are not for free building, being a mad scientist, freestyling and building new circuits. All of the components on the ATECH board are designed for a specific purpose. If you hook them up backwards, if you hook them up with too much current, you can burn them up. So do not, under any circumstances, free build. You're going to have an example of a circuit to build, and that's the circuit you should be building. If for some reason I would like you to build a bigger circuit or add on to a circuit to expand on a topic or try to solidify some learning, I will ask you to do so. If it's not on the example in front of you, please don't build it. There's reasons for that. There's components that are intentionally flawed. There are components that, again, won't take the current. Next thing you know, you're letting the smoke out of something. And this really could get you in trouble. You could face disciplinary action. These boards are expensive, and if you can't follow instructions on something as simple as a board in front of you, I'm going to have a bigger problem with you as a student going forward. So this is your time to build some trust with me. Do not go forward and build things that you're not supposed to build. Okay, so we have do not build circuits that are not on the board or in your book. Do not replace the switch fuse without the instructor approval. So there's a fuse that you can blow, and a lot of students will blow them. If you're blowing them on a regular basis, it's probably because you don't understand what a short is, or you're just working really sloppily, and I don't want you just replacing fuses over and over, because I need you to understand that there's repercussions for shorting out circuits, and so I want you to work more conscientiously. So please don't replace fuses without my permission. Do not work ahead in the book without approval. So if you finish a section, go ahead and stop, raise your hand, let me know. I may tell you to go forward. I may tell you to stay where we are and wait for the rest of the group. Ask questions, okay? This is a rule. It's a rule to ask questions, preferably before you screw something up, okay? If it doesn't make sense, ask questions. Think before you ask a question, okay? So this is also a rule. I want you to think about it. I want you to read the example or read the instructions. I want you to look. I want you to really try to figure it out for yourself beforehand. But if you can't figure it out, please always ask questions. All right, there's that good-looking guy. All right, so here's the front of your ATECH board. The front of your ATECH board, at the top here, we have some voltage ports. And this one here is positive 12 volts, and it's in red. Then we have negative 12 volts DC, direct current. It's also in red. Then we move over to the next set. This is a positive 5 volt DC and negative 5 volt DC. And the reason we run 12 and 5 volts, well, the car runs 12 volts most of the time. And when we look at voltage on a car, it's almost always like 12, 6, or possibly whatever the alternator's putting out, which could be up to 14 volts or more, depending on the system. But there is a cutoff there. Whatever the voltage regulator is regulating the voltage at. All right. The two blue ones over here, they don't have a positive and negative because they're alternating current. So alternating current goes above and below the negative all the time. So there's just two ports there so that you can complete the circuit. All right. Rushtastic says we will use the 12 volt DC the most. Okay, so this top one up here, if you're following my arrow on the screen, that's the one we're going to use the most in lab. But they're going to throw you for a loop every once in a while, and they're going to use this 5 volt or this 12 volt AC. So you do have to look at your examples, and I'll show you what that's all about here in a second. Down here, these two little nodes, these are both chassis ground, okay, or negative. And this little wing nut looking deal here in the center, that's your handle for the lid. And so you're going to lock and unlock that and lift up the handle. All right, this is what a component card looks like. And most of the component cards have a letter at the top, okay? And so when you're going through your example, you're going to look for that particular card, and I'll show you what I mean here in one slide. All right, so here's what I was talking about earlier between whether or not you need to use the 12 volt or the 5 volt. Here, obviously, the circuit looks like it's connected to this 12 volt, so obviously that's the power tap that we want to be on. If we didn't want to be on the 12 volt, they would just shuttle this 5 volt over here, and the 12 volt will be over here disconnected. And then the component cards, as you see this dashed line, in the electrical world, that means a component, okay? So we're using component card A, and in that component, they have a fuse, a 7.5 amp fuse, and a switch. And then the B card has one big tail light on it, and the other B card, another big tail light. And then down here at the bottom, this is that ground I was just talking about. That's this ground down here. Okay, that's this ground. So we build from the top to the bottom. So from the top, our component cards, and then down to ground. And so you'll be able to see that as we're building, and it's pretty simple. I mean, if you're hands-on, you'll enjoy that part of it. It won't be a big deal. All right, so here's our component card. Okay. Let's make a circuit. Okay. So right now I'm just going to go ahead and draw on here. And we're going to choose my pen. One second. The pen is being a little bit weird today, so I have to play with it a little bit here. All right, so I'm going to take one of my red wires, and I'm going to go from here to here. Okay, and that's my positive. Okay. And I'm going to go with my negative in black, and the wires on the board will be red and black. Okay, and then I'm going to give my bulb ground. I better connect that a little bit better down here. There we go. Now it's grounded. Okay, and now, if I've done this correctly, my bulb should light up. Oh, and there it did. Look at that. All right. One thing I will note as we're dealing with this is right up here in the corner, right there, that should be a red light. So that red light should come on. And if it doesn't come on, that means your board doesn't have power. Okay? So you're going to want to make sure that that light comes on and everything is kosher. And if it's not, then it won't work. Okay? All right. Can we control the load? If you look at this, is there a switch in there? No, we can't control the load. There's no switch. It's going to be on all the time as long as these wires are plugged in. And we don't necessarily really want that. What else is missing? So let's take a look. Let's think about that. All right, so now I've added a switch. Now we can control the load because I've got a switch. But something else is missing. Can you find it? Do you know what it is? So if I build this circuit, I bring my red over here, and I'm going to use green whenever I'm connecting components together, and I'm going to use black anytime I'm grounding something. Now if I flip that switch, this will work, okay? All right, so there you see my actual wires in place. It looks like it's going to work, right? So if I flip my switch, if I close this switch, there it goes. It comes right on, right? Because I have everything I need. I have power, I have a path from the switch to the bulb, and I have a path to ground. And actually I should have used black on this one. I didn't notice I made that mistake. All right, something is still missing though. What's missing on this? Okay, it's this fuse, right? It was the circuit protection. Okay, so we need to use the component card A, not the component card T, that has the actual fuse. Okay, so we have a fuse and a switch and everything else. Now, if I hook this up, we're gonna connect at the A portion. So we're gonna go from. Let me go ahead and switch my stuff here. For some reason, it didn't want to change colors. Let me see if I can do that a little bit better. Red. Okay, I want to hook up there, and then I would use my green wire coming out here to whatever component. I don't want to use this center port very often. There's almost no reason to use it, except if I was going to take my meter probe and put it there. Okay, if I wanted to find out if I dropped any current or voltage across this fuse, okay, the fuse that's inside here. All right, so here we have the whole system again. Now, if I build this, I'm going to build it just like this. I'm going to go with my red wire, and I'm going to go from red to there, right? I'm going to go from green there, and then I'm going to go black right here. Okay, so now I've made that circuit, and if I've done it correctly, everything should work just fine. And we'll look in the next one. Okay, now I have everything I need, and I built that circuit just the same way I built the last one. Got my red wire to the top of the fuse. My voltage is now going to flow from here to here. Then I'm going to connect my green wire from here to here. Now I have power to the bulb. Voltage is going to flow through the element, and then I have a ground, and so it is going to actually light this bulb. So we have the fuse, the switch, the wires, the load, and the source. Those are the 5 elements we need to have in every elementary circuit. Now, can we not have a fuse? Yes, if it's computer controlled, we cannot have a fuse. Can we not have a switch? Sure, if it's computer controlled, again, we could not have a switch. It just depends. But when we talk about rudimentary circuits and elementary circuits, we're going to just talk about 5 things, and especially on these ATECH boards, or on the ATECH boards rather, sorry. We need a power source, a fuse, a switch, wires to connect all of them, the load, and then the ground, okay? And that's pretty much what you're going for as far as this goes. All right, so I want you to notice how bright this bulb is. I mean, it's almost like I can't even catch the bulb with photography. It's so bright. Now, what I've done in this circuit, it's a series, right? Everything just kind of runs through everything all the way to ground. And there's really one power source and one ground source. Now let's look at this with regards to our sorry, it's a parallel circuit. I don't know why, or I'm sorry, it's still a series circuit. Sorry. So let's look at the series circuit. We're running through the bulb, or I'm sorry, running through the fuse, through the switch, through the green cable to the bulb, through the green cable to the other bulb, and then ground. So if you look, there's only one power source and there's only one ground, and everything is running in a series, okay, in a big line, okay. If we have more than one power source and more than one ground source, then we may have a parallel circuit, and we'll look at that. So see how with the photography, I really was able to catch that. I really was able to catch that voltage source. Sorry, I'm fumbling a little bit, guys. I apologize. I really was able to catch this bulb and see the element and the whole 9 yards. It's lighting up. Now, if I go to the next slide, I have 2 bulbs here in parallel circuits. And so let's look how this is built differently. So we come out of our power source with our red wire. We go through the fuse, through the switch. And then from the switch, I have 2 power sources going out, or 2 wires going out. So I'm somewhat, I'm splitting the wires off. Now, what happens is if I have 12 volts at the top here, I'm going to have 12 volts here and here. Okay, so let me go ahead and select my pin again. Now I'm going to have voltage running. Let me make sure it's red. It's going to be a pain, I think. Let's see. All right. I'm going to have voltage flowing to the bulb there. And I'm going to have, if I have 12 volts up here, I'm going to have 12 volts down here and here. Okay, and that's significant because in a series circuit, that's not exactly how that's going to work. So both of the bulbs are really, really bright, and that's kind of the difference. And if you notice, each one of these bulbs has its own ground. Okay, they're going to the ground separately at different points. Okay, so there's two grounds there. So 2 powers, 2 grounds, and that's going to make a difference, especially when it comes to how the circuit actually works. Okay, so let's go back up. Now let's talk about what's going on here. So I have 12 volts right here, and it flows through this wire and comes down here to the bulb. And we'll talk a little bit about this because you're going to get some other lessons. But I have 12 volts right there. But this bulb, these two bulbs have to share the voltage. Okay, they have to share it. So this bulb is going to use 6 volts. And this bulb is going to get 6 volts. So right here, there's 6 volts left over after this bulb used 6 volts, and then this bulb used 6 volts. So we'll talk a little bit about that. And then at the end of the circuit, right here, okay, we go to ground, there should be like 0.01 volts left. And we'll talk a little bit about this. Depending on where this video ends up in the series, you'll either have the knowledge that goes with this or you won't, depending on how it works out. So it depends on whether or not you skip around or I skip around. But that's what you're looking at as far as this particular example. All right, now we look here. Now we have a small bulb in this circuit, okay? And the small bulb is going to act similarly, I should say. We're going to come out here, we're going to go 12 volts, right? 12 volts flow through the switch. So we have 12 volts right there. We're going to go through our green wire with 12 volts, right? And so we have 12 volts right there. And so this bulb right here, it gets 12 volts. So it's going to be really bright. It's going to be as bright as it was designed to be, getting 12 volts, okay? And sometimes it might even get a little bit more voltage because, why? Because our alternator oftentimes puts out more than 12 volts, right? More than 12.6, okay, which is our battery voltage. All right, so now our bulb is going to take that strength, take that power, convert it into heat and light, and we aren't going to have very much left on the other side. So our ground comes up and kind of feeds this, right? Well, when our voltage comes down, we actually will have just enough voltage to go all the way back. And so right here at this tap, we might see I did that kind of bad, 0.01 volts left over. Okay, that's what you're going to see at the end of that. And I know that gets a little bit messy, but that's how our voltage is flowing through that circuit. And that's what's happening during each leg of that circuit. All right, so now let's look again. We've added another bulb. We're still in series, okay, but we've added another bulb. So let's look at that again. So 12 volts comes out. We go in there. We go through the fuse, okay, through the switch, through this wire, our conductor, and into the bulb. Well, we know because of the way electricity works that we're going to share that 12 volts between these two. So we had 12 volts. We had 12 volts right there. So this bulb is going to burn 6 volts. Okay, I'm going to come out of here, and my graphic kind of covered it up, but we're going to go here. Now I have 6 volts right there. Okay, and so 6 volts comes to the bulb, and this is going to consume, oops, I did that all wrong. Oh, well, now we're going to have an issue with erasing, I think. We've been having a problem with erasing today. Yep, and none of the tricks are going to work. Sorry. So we are going to... Let's put another flag over here. 6 volts is going to be burned, used. Okay. So right here, when our voltage comes out, we will have voltage coming out, but it'll be 0.01. Okay. Something to that effect. And then we come through and we go back down to our ground, and everything goes back to the battery, okay, or our power source. All right. So I know that makes a little bit of weird sense, but we'll go over it more and more, and we'll build these circuits, and you guys will get some hands-on experience. But for those of you that are good at looking at this board and reading it, great. You guys are probably the audio-visual learners. I have a mixed learning style. I'm a little audio-visual. I can learn and retain that way, but I'm mostly hands-on. I can learn it, but it won't solidify it until I put my hands on it. So when you're watching this, I want you to try to learn it. Don't cop out and say, oh, I can't learn from watching. I have to do it. Yeah, most of us do have to do it, but I'm going to bet that a lot of you are like me, because everybody wants to be like me. Not. So you're going to want to learn it here and solidify it on the board. There's a ton of our learning that's going to happen in an audiovisual presentation in our industry. We watch a lot of training videos. We watch a lot of stuff. So you have, if you're saying right now, I can't learn from watching a video, you need to start to change your mind and say, yes, I can learn from a video. There are things I can learn from a video. There are things I can learn from reading. But all of us are probably going to have to solidify our learning by putting our hands on it and touching it. If you can't do that, we need to work on that. You need to raise your hand and say, hey, Mr. Rush, I need you to teach it a little differently. I need to put my hands on it. I need to do something. And I will. We will stop and we will change the way we're doing it. Or I'll tutor you by yourself. So don't get too far lost. And also remember that electricity is going to take us a long time to learn. It's not it's not a sprint, it's a marathon, and we're going to keep coming back to it and back to it and back to it. Okay? So don't feel like if you can't get it today, that you'll never get it. All right. So let's look here. What are we doing here? If you look at this circuit, and really what I want you to do with this circuit is I want you to kind of analyze it. And man, I do it with my hands. So when I analyze the circuit, I want to try to look at it on paper, or I can try to do it with my hands. And in this case, I can see everything, so I'm going to go ahead and do it with my hands. I'm going to trace this wire. So I have power going to this. It comes up. It goes through my fuse. Goes through my switch to these 2 wires. Oh, okay, so now I have 2 wires going out. So if I have 12 volts right there, and I can put a meter there and figure that out, I'm going to follow this. I'm going to say, okay, there's 12 volts. And I want to verify that. I want to put my meter there and find that out. Or my power probe, and you guys will figure out what a power probe is shortly. So now I've got 12 volts there, 12 volts there. Okay. And now let me look. Okay, now I've got voltage going through this bulb, out, into ground. And I've got voltage coming through here, out, into ground. And so I have 2 powers, or 2 power sources to each one of these loads, or 1 to each load, I should say, but I have 2 in this circuit. And I have 2 paths to ground. So this is definitely a parallel circuit. And if you look, you have two circuits running parallel to each other, right? Parallel, okay? Not in a line, not daisy chained together, okay? And that's important to know. And what I'm going to do when we build really complex circuits is I'm going to come over and I'm going to look for you to be building your circuits in parallel. And we'll talk a little bit about that and what that looks like and how we do that better than, there's certain ways to do it to where it's really clear and certain ways to do it where it's not so clear. And so we're going to try to always make sure we're doing it in a clear way where it makes sense. All right. All right. So here's a question I'm going to pose to you. And this is something you're going to learn on the board, but this is something that I want you to think about right now. And let's trace this circuit so that we can figure out what is going on. So we've got our red wire coming out. Okay, it's going through our fuse, through our switch, coming to here. Okay. Well, let's look. Now, this bulb is not lit up. Could it be a bad bulb? And so we'll talk a little bit about that and why could it be or could it not be, things like that. But this bulb is lit up, right? This bulb is nice and bright. It's lit up. So that tells me it's getting voltage and it's getting ground. So let's look at that. So it's getting ground right here. Okay, so it's got ground coming up to it. Okay, so it's grounded. So really the only way for it to get voltage is to go through this bulb. Right? So we went through this bulb, we went out. Okay? But why didn't this bulb light up? It got voltage, right? And then you know there's a connection in there, right? So what's going on there? So we come out, this bulb, we know it got all bright, and it came through, and the voltage went back to the battery. This is a weird one, right? This is weird. So why is this one not lit up? And this one over here is having a party. It's burn, baby, burn. It's like, yeah, woo, I got all I need. So we're going to figure out why this is the way it is. I have brought people into our lab, my robotics students, adult technicians who have been in the industry a long time. And very rarely does anybody give me the answer, the right answer to this scenario. It takes a real understanding, okay, a real understanding of basic electricity in order to answer this question. So if you don't know now, great. If you think you know now, great. We're going to teach you the real reason when we get down into the lab. There's an exercise that goes through this particular scenario. Woohoo! So that is the end of this PowerPoint lesson for today. Please do your reading. Please, as always, do your own homework and ask questions. I'm available a lot of times during the morning time before class starts. I'm available after class. We always do a question and answer session before we get started. So if you don't understand something the night before, providing you've done your homework, normally we'll answer those questions and things like that as we go. All right. Look at my little Picasso drawing. I'm so proud of it. I'm going to go ahead and sign this thing. That wasn't my best signature. I'm going to have to work on my signature here. Yeah, it doesn't work very well with this pen. All right. Peace out.